Hello, thank you for joining today's webinar. Today's webinar from Index Engines is about cyber and ransomware. We're talking about our innovative approach to cyber attack detection and recovery. My name is Jim McGann. I'll be doing the presentation today. My contact information is there. I'll put the email address up at the end of the session as well. If you do have questions, feel free to email info@indexengines to get an answer, or there's a Q&A section on your screen where you can chat and we'll answer your question either during the session or after the session is over. Okay, let's get started. For those of you not familiar with Index Engines, we've been in business since 2004, so we've been in business quite a while. We started in the e-discovery space and evolved to governance and security applications. And really our claim to fame is the ability to index user data in a very efficient manner, large volumes of data, including data that's in backup formats, and I'll talk about that in the session today. We have a wide range of partners. Dell EMC is one of our strategic partners. You'll see that in the presentation, and customers that are using our technology globally. So, you know, this is the standard fear slide that most cyber presentations lead with. But I think there has been significant change recently in what cyber criminals are doing, doing to attack customers. There's definitely been an increase in attacks that we've been seeing. Part of it is due to ransomware as a service vendors. You can, call 800 numbers. They have online help desks and financing, and they share revenue with you, and you can, pick a target and the type of attack you want to execute. And without any technical expertise, you can execute an attack on anyone, your school, a hospital, a local company, your ex-employer. So it's very easy to execute a ransomware attack. We've seen also the second half of last year, we saw a change in what they're doing. They're making more money by threatening to publish data online if the ransoms are not paid. So if you're a healthcare organization, for example, publishing personal health records online is really taking it to another level. So the fines that they're asking are increased. And finally, we're seeing attacks become more sophisticated. This is an attack at Epic Global, an e-discovery vendor that happened last week. And in this case, they're using, multiple components, using TrickBot to go in and enter the data center and kind of harvest passwords and make it available for the root ransomware to enter and encrypt data. So it was a multi-pronged attack that had human intervention in between, which is a new approach. So they're becoming much more sophisticated. So really the game is changing out there, and the cyber criminals have really upped the ante in terms of how they're approaching these attacks. So, our opinion is that, existing security solutions are not enough. I don't think that's a controversial statement. If they were enough, we wouldn't be seeing these attacks. But we're seeing the proactive defenses, your real-time security solutions, from McAfee, from Symantec, things like Varonis that does real-time behavioral analytics are not 100% effective. Cyber criminals can circumvent them and get into the data center. We're seeing the post-attack recovery process, when customers do get attacked, we're seeing the post-attack process becoming more and more time-consuming, require more resources. They set up clean rooms in order to restore backups into the clean rooms to manually check them to see if they're good, and more money. So, the existing process really needs to change. So CyberSense is not a replacement for existing security solutions. It's really adding another layer of protection. And really it's assuming that these real-time solutions are going to fail and the data is going to be corrupt. CyberSense is really kind of the last line of defense that looks inside the data, looks inside files and databases for those signs of corruption. So knowing that the real-time solutions will fail, they are. Looking inside the data will allow you to really understand how it's changing. And if it's changing in a way that's indicative of a cyber attack, you'll know that there's a problem that needs to be addressed. So CyberSense works in a very simple way. Observes how data changes over time. So it compares data, like a Word document or a PDF from Tuesday to Wednesday to Thursday, if you're running analytics every day. It looks inside the files and databases for signs of corruption. So it goes deep inside the content to look for signs of attack, encryption, stripping out content, file deletion, for example. And all this is automated through analytics and machine learning that'll audit the data and monitor. So the idea is that CyberSense is an automated process that'll alert you when there's data corruption. And then if there is data corruption, CyberSense supports post-attack diagnosis and recovery. So what types of data does CyberSense support? Unstructured files, that's common data types that cyber criminals typically attack. Word documents, contracts, agreements, intellectual property. They also attack databases, Oracle, DB2, SQL, SharePoint, Epic Cache if you're in the healthcare space. They will encrypt pages inside these databases. We're also seeing them attack core infrastructure, your DNS, LDAP, Active Directory. So really corrupting the infrastructure that would really impact a customer that would need to rebuild the network environment. So all sorts of data types are supported by CyberSense, and it really is required to have a full view into content where cyber criminals are doing corruption. So the other important point I mentioned in the introduction is that CyberSense not only supports scanning of network data, so crawling through network file shares, but it also supports direct scanning of backup data. So backup data being your, Dell EMC Networker, Avamar, IBM Spectrum Protect, Veritas Net Backup, Commvault. So customers use these data protection softwares to protect data. We have integrated CyberSense to be a component of that data protection software so that it can directly index data as it's backed up. So that's a very important point, which I'll come back to. So the direct indexing of backup images, that's part of our unique intellectual property here at Index Engines, is the ability to index the contents of these backup images without the need for the backup software. So all indexing is full content, goes inside the proprietary backup format and indexes the data inside these formats. So it's not checking the integrity of the backup image, although it does that. It's designed to check the integrity of the data inside the backups. That's a very important point. This is what we're supporting today. So Dell EMC, their Networker, Avamar, their Power Protect Data Manager, which is their new offering, Veritas Net Backup, IBM TSM, and Spectrum Protect, and Commvault. We're adding support for others in the future, but those are the main applications that we support today. So there's really two deployment options here. So there's a proactive deployment, which is, obviously best case scenario that customers would put in proactive solutions and they can integrate into their data environment, typically through the backup process, as I mentioned, and have ongoing observations. So they can scan either backup data or primary data stores, data sources, servers, and so on, and do integrity audits to figure out how data changes over time. So that's proactive. If you put CyberSense in today, CyberSense will audit that data to say, hey, does this data look good? Is it clean? Is it free of corruption due to a cyber attack? Or are there areas that need to be cleaned up? And once it is cleaned up and you have a good baseline and a good gold copy, as they call it, then ongoing observations will really alert you when data corruption starts to occur due to an attack. And some of these attacks occur fast, some of these attacks occur slowly. So these slow attacks where data is slowly corrupted, CyberSense would alert you of those attacks. On the reactive side, so if you do not put in something like CyberSense to audit your data, there's the ability to create these post-attack observations. So to scan some of these backup images, the corrupt image and one of the clean images, to create different observations of the data. And that would allow for an intelligent restoration process that eliminates the clean room process and allows you to restore only the clean or good data back into the network. So there's really two different approaches here, and I'll speak about both of these. So again, the deployment options, proactive deployment, here's some examples. So you can scan backup data. I mean, that's probably the preferred deployment option because backup is a process that's in place today that accumulates and gathers all the critical data. You can set up CyberSense to scan that production environment and create analytics and see if the data is clean. Most customers, that are backing up hundreds of terabytes or petabytes of data, you don't really need to scan everything. Most customers are doing maybe 10 to 20% of their data just to get a sample set to see if data is clean or if there's corruption that occurs. So scanning backup data is one deployment. Dell EMC has integrated this into their cyber recovery vault solution. So it's a isolated vault that isolates critical data into a offline copy of that content. It's hidden off the network so that cyber criminals don't even know that it exists. And that's a packaged solution that Dell EMC is selling today. CyberSense is a part of that solution. And then network data scans. So network data scans is just scanning file servers to do audits to see if data is clean. We have a number of partners that are doing that today that are helping customers understand their environment. The Dell EMC Cyber Recovery Vault is probably one of the most sophisticated solutions on the market today, just because it's fully integrated, fully automated, and isolated environment. Being able to scan backup data and network scan CyberSense would be out and exposed on the network. So if cyber criminals get inside the data center, which they tend to do, they could see that CyberSense is there, and they could do some malicious behavior there to corrupt that deployment of CyberSense. So, I think the isolated environment is one of the recommended scenarios out there. So that's the proactive deployment. On the post-attack incident response type deployment, so for customers that have been attacked, typically what our product is used for is to scan historical backup data. So you can go scan different backup sets. So obviously the current backup set that was just created is full of corrupt data. So getting a view of what was corrupt and then going back in time and scanning a data set that is not corrupt. So you can compare the clean data set with the corrupt data set, and CyberSense would give you basically a hit list of the backups that need to be restored with clean data in order to recover. We also get, our software also gets used in just network data scans. We have customers that have ongoing corruption due to cyber attacks that they may have recovered from, but they have concerns that their network file shares contain corruption. So scanning those network file shares is another deployment option. So you can see there's a number of different scenarios. CyberSense is a software that can be flexibly deployed in a lot of different environments. So this is the proactive workflow example. So the first step is a scan. So CyberSense needs to see the data and scan the data. So whether we're going to be, CyberSense will be scanning a backup image or scanning file shares, a scan is an observation. And CyberSense depends on observations, which is really kind of point-in-time analysis of how data changes over time. And that could be automated, setting up just scan jobs that are scheduled to run on a daily basis. Or if you have large volumes of data, you can set it up to run on a periodic basis. When the scan occurs, analytics are generated. So the analytics are over 100 analytics that are indicative of a cyber attack. So it's things like what we call a entropy score. Entropy is the random disorderness of a file or a page of a database, for example. So CyberSense has an entropy score from 0 to 100. So if you scan, say, a PDF and its entropy score is 47 on Tuesday, 47 on Wednesday, 47 on Thursday, and then on Friday it goes to 99. 99 is indicative of a cyber attack. So, or encryption, I'm sorry. So that PDF suddenly becomes encrypted, which may be normal user behavior. But one of the other analytics that CyberSense uses is looking inside the header of the file, so the header of that PDF, and saying, hey, the header says this is a PDF, what is the extension? So at the same time that it was encrypted, the extension was changed to .lol or .encrypted. That is an attack vector. So CyberSense will generate all these analytics, including signs of corruption, signs of mass deletions, entropy, as I mentioned, and then feed those to a machine learning that has been trained on all the common attack vectors. So if it sees, for example, that PDF becoming encrypted and the extension being changed, that's an actual attack vector that's very common, actually, where they encrypt a file and change the extension, append the .lol or .encrypted or .loki to the extension. So the machine learning would basically kick out like a red light, green light scenario. Red light if there is something wrong. Green light basically saying, hey, we just looked at your data, looked inside every file and every database, and everything looks okay compared to the previous observation. If that's the case, then that process will repeat over and over and over again, which is why it really makes sense to be integrated with the backup process, because that repeats over and over again. So you're extending the backup capability in a proactive environment to go from data protection to cyber protection. If the machine learning kicks out a red light alert, basically there's a number of forensic tools, forensic reports, which allow you to recover. And the forensic reports, could be brought in even if CyberSense was not involved proactively, so you can go in and kind of reactively go in and discover what's going on. So in the proactive deployment, detecting and knowing when it happens, obviously that's best case scenario, is proactively looking at your data and knowing that something has happened. The second item there is investigation. So that's available in reactive as well, to investigate what happened. So who was impacted? How much damage was done? So if CyberSense comes back and says, hey, 5 files were corrupted, okay, there's an attack that's occurring, it seems slow, 5 files were corrupted, we can recover from that. If it comes back and says, hey, tens of thousands of files were corrupted, you may want to look at where those files are. If they're all located on the same server or owned by the same user, that's interesting information that allow you to investigate what's happening. What was attacked? Listing of the corrupt files. Where is the source? What user account and what ransomware was used, and I'll show you how CyberSense helps with that. And when did it happen? What backup sets contain the last good version of the data? And that's what we see with most customers that get attacked. City of Baltimore from last year got attacked, and within hours or 24 hours or so, they knew exactly where the ransomware was and what the ransomware did, but they couldn't find the good backups. It took them months and months and months to figure out what backups were good. They don't have the confidence to go to their backups and say, hey, we know that's good and we can restore it and get back in business. They lose all confidence that the data has integrity. So figuring out what's the last good version is critical. And obviously the idea is to minimize downtime, whether you're doing a proactive or a reactive deployment. Minimizing downtime is critical. You want to get the business back up and running, or if you're proactive, to avoid any business interruption whatsoever, because not only does it hurt your revenue and activity, but it also creates kind of public embarrassment out there when, especially someone like Epic, they got attacked, who's a governance company that holds sensitive, secure data for litigation. That becomes a very much a public embarrassment in the market. So the forensic analysis. So this is when you do get attacked. So this is either having CyberSense in there proactively or not having CyberSense. It's basically a very, very similar workflow where the post-attack reporting tools allow you to really recover and diagnose very effectively. So in a proactive deployment, the forensic data is immediately available for rapid recovery. So proactively, you're constantly creating these analytics and understanding what's happening. In a reactive deployment, what needs to happen is scans of data required to understand how it changed. A minimum of 2 scans. As I mentioned, a scan of the corrupted data in the backup would be preferred here. That's the best way to go. So take your recent backup where data has been corrupted and it's been corrupted, and then go back in time to a clean backup and scan that as well. So that'll give you 2 observations of the data, and that'll give you the same post-attack capabilities that I'm going to go through here, that allow you to really create the intelligence you need to go and figure out what is a solid recovery plan without having to create a clean room and restore data and check the integrity manually. This will automate that process. So the post-attack workflow. So as I mentioned, CyberSense scans data and creates an index, looks at how data changes over time, whether it be 2 scans in a post-attack environment or dozens of scans in a proactive environment. Analytics are generated. So there's over 100 statistics or analytics that are generated every time, and they're compared to previous statistics, and they're fed to the machine learning. So machine learning has been trained on thousands of Trojans that are out there today and over 20 attack vectors. So the interesting thing is, as we educate and train machine learning, we don't see it learning that much more because the attack vectors are not really changing. The cyber criminals are successful. They're making lots of money. Their attacks are working. So why would they change their behavior? There's basically 6 attack vectors that are the most dominant. They're 99+% of what's happening out there. and they're using them over and over. They're changing the names of them, modifying them a bit, but they're basically the same, and they've been in place for years. So when CyberSense does a scan, it kicks out the attack vector. So if the cybersecurity folks at your customers know the attack vector already, CyberSense will validate, yes, that's exactly what's happening, and that's exactly what's being executed. Most importantly, CyberSense will kick out the corrupted list of corrupted files. So if it's 5 files or tens of thousands of files, that list would be kicked out, full file name, full path of where those exist. Important there to get an idea of, is it 5 files or is it tens of thousands of files that are corrupt? What basically happened here, and where are they located? Who owned them? What type of file they are? CyberSense will also be able to help you find the breached user account and executable. So there is an ability, proactively with CyberSense to put the event logs, into a vault, or to scan the event logs if you're doing, indexing off the production environment. And by doing that, you can look at the last user that touched the corrupt files and the executable that was used to corrupt the file, such as encrypt, the file becomes encrypted, what executable encrypted it. That would be your malware, and that would be the user account that's breached. If you don't process the event logs with CyberSense, because they are big and they roll over quickly, what you can do is use the full file name and path of the corrupted files, upload those to event log management tools like Splunk or Varonis or things like that, to say, hey, on these files, who's the last user that touched them, and what executable did the modification of these files. Again, that would give you the same information, the breached user account and the actual malware or ransomware that was executing the corruption. And then finally, CyberSense automatically will tell you the last good copy of files. So having the last good copy, and this is these files have been scanned full content to look inside them to check the integrity. So instead of having to, in a post-attack world, store these to a clean room to figure out, hey, is this file good? Is this database good? Instead of guessing and hunting and pecking for the good stuff, CyberSense will automate that process and give you the confidence that, hey, those files are good for restore, and that's the last good version of those files. So more detail on all this. As I mentioned earlier, that CyberSense is integrated with the Dell EMC Cyber Recovery product. This is their cyber recovery dashboard, and the CyberSense alerts would be a critical alert that would appear in the dashboard. So when data is replicated to this isolated cyber recovery vault, it is scanned and analyzed for any signs of corruption. If signs of corruption exist, then that alert will be sent out to the dashboard, and it's an easy view to see, hey, something's happened here. If you don't have cyber recovery, the Dell EMC product, CyberSense sends out an email alert. So the email alert would be sent out to whoever the administrator is, saying, hey, there's a bunch of data there that tells you about the scan job that was run. The important point here is infection found, yes. You don't want to see that, but if you see that, there's a run book or a playbook that you can execute following that alert that would help you diagnose and figure out what happened very quickly and recover from that very quickly. So here's the alert. With the alert, there's a series of the analytics. I mentioned there was over 100 analytics that are generated. This is the raw analytics. You don't really need to look at this. I'm just showing this here for your entertainment to show that they're real. So you see, a lot of them around entropy, a lot of them around mass file counts and deletions, or a lot of them around, known malware extensions and so on. So these are all the analytics that are generated. What you do need here is at the bottom is the analytics, the output from the machine learning say, hey, based on how the analytics change here, it looks like you're under attack by attack vector number 6. So that you need that information. There's a detailed list of all the attack vectors that CyberSense sees. Here's about 28 of them. These are the ones that are supported by CyberSense. The top 6 there highlighted in red are 99+% of what the cyber criminals are doing. Like I mentioned, they're not changing their behavior. So CyberSense is looking at those dominant attack vectors, but also looking at other more obscure attack vectors as well. So in that previous alert, it was attack vector number 6, so it was strong encryption with obfuscated, I can never say that word, file name. So they're corrupting the file name and encrypting the data. So that's what's happening. So if you see some signs of attack and you're like, hey, what's going on? You'll know exactly what the attack vector is. Your cybersecurity folks would, with that description, would know the type of malware they should be looking for. So here's the first step in doing kind of a post-attack forensic on what's going on. So this is the interface for CyberSense to search. So I mentioned that CyberSense, when it sees corruption, it automatically tags files. And you see there underneath the tags, there's the original file, which is the last good version of the file. And then there's the suspect file. That's the corrupted file. And if you see in the listing of files, you'll see the number of files and the volume of files that were attacked, the type, where they're located, all that information about it that gives you complete insight into what's going on out there. But if you look closely at that report, you'll see in the middle there, you'll see one with a word icon next to it, the 0001.doc. That's the last good version of that file. Right above it, you'll see that the icon is gone. You'll see it's the same file name, but they appended .fun extension on there. .fun is actually interesting. It's a valid extension from a valid application out there. I think it's an engineering application. But cyber criminals, it's pretty obscure. So cyber criminals use that because a lot of the metadata-only scanning tools would say, hey, .fun is a valid extension. But we know in this case it's not being used as a valid extension. It was appended to corrupt the file. And you can see the contents of the file was corrupted because CyberSense can't even taste the file or go inside and read the header because it's all corrupted. If it was able to read the header and say this should be a Word document, you'd see a Word icon there. So you can see a comparison there above and below of the corrupted file, and below that, the last good version of that file. You can run a series of forensic reports. So if you're called into a customer that has been attacked, you can get the report there in the upper left there of all the corrupted files and say, show me where the corrupted files exist per server. So you can see here, server A on the upper right corner there has the dominant number of corrupted files. So that's a server that's heavily corrupted. The bottom right will tell you corrupt files by extension. So you see some of the extensions there are .fun and .lol and .encrypted. Those are clearly files that have been attacked by an attack vector that appends to the file extension and corrupts them as well. On the lower left file, you can see corrupt files by SID. So if you're doing this in a backup environment, you're not really connected to Active Directory in that scenario. So you can't resolve these SIDs, but you can see which users are being impacted by data corruption. So, post-attack forensic reports that allow you to really understand what's happening. Back to the search interface. So that document that I was talking about earlier, the 0002.doc.fun, you see it highlighted there in that orange above. If you look at the metadata associated with that file, so you don't really need to examine every file. I'm just giving you this view into it so that you see the detail of what's happened. You can see now the file type is unknown. So CyberSense hasn't been able to detect what file type is. So this corruption basically corrupted the file so much that it can't be read. If you go down below there, you'll see the entropy score is 99. So 99 signifies encryption. So you can see here the file was corrupted. They appended the .fun extension, and it's encrypted as well. So classic attack vector, classic type of data corruption. So if you're using CyberSense to recover and figure out, hey, what backup sets do I need to recover in order to get my business operational again? This report is easily generated from CyberSense. When you scan data, whether you're proactively scanning data to understand how data changes over time, then this could be generated, instantaneously once corruption occurs. If you're going in post-attack, you'll need to do at least 2 scans of the data, scan of the corrupted data and scan of the last good backup. And this would give you a listing here you see on the right side highlighted in red. Well, actually in the upper left, you can run a report and say, hey, show me the last good version of the file. So you'll have the last good versions of the files. And because CyberSense also captures the backup metadata, you can summarize it and say, summarize it by backup set. So what backup set are the last good versions in? And you can see on the right highlighted in red, those are all the files that were corrupted, a few thousand files. And just to the left of that, you can say, hey, these are the backup set IDs that you'll need that have the last good version of these files and the backup time when they were backed up. So if you've got these backups, which you should, you can just take these backups and restore them without creating the clean room and checking to see if they're good, because CyberSense has already done that for you without restoring anything off of these backup images. You can take these backup images and with confidence restore them into production, and you'll know that all the good data has been restored into production. So a question we typically get here is, well, how do I know the ransomware still isn't on one of those backups that I'm restoring? What you can do is at this point, you know the attack vector, so you should know the ransomware that was executed, that was actually corrupting the data. You can go and you can upload the MD5 or the document signature of that ransomware to CyberSense, and you can search on that document signature. So every file or database that's indexed with CyberSense creates a unique document signature using an MD5 hash. So CyberSense would do that for the ransomware as well. And if you download those document signatures from, standard security sites and say, hey, are any of these signatures, meaning malware, in these backups, CyberSense would show you a hit if that did exist. And you would need to restore those backups and then quickly go and find that specific ransomware and go delete it off primary storage. So that covers you in terms of being able to do restore with confidence, so that if there is ransomware in those clean backups, you'll know to be able to get it and clean it post restoration. So, this is the the end slide here. So wrapping this up. So I think there's a couple of approaches here. In the post-attack forensics, the reactive deployment, as I mentioned, requires 2 scans, a pre-attack scan and a post-attack scan. So simple to do. So you could walk into a customer that's struggling to recover from an attack, and they're like, where's my last good backup? CyberSense can go and scan those and with confidence tell you where the good backups are to recover from. So we're taking down, the recovery process from, days and weeks to, hours and short number of days. So again, post-attack is going to give you the attack vector, the last good file, listing of backup sets required to restore, as I showed you, and we'll only restore the last good files. The idea is to avoid creating a clean room environment and restore data with confidence, because you have CyberSense checking the integrity of this data. That's it. So those are the capabilities. I know it's a couple different approaches here. We were trying to keep this to 30 minutes. 4 minutes over here. So we'll hold off on questions for now. Anybody that did ask a question, we'll get back to you directly. If you want to interact with us or engage with us to go in a deeper dive or see more so how CyberSense works, I'm happy to do that and happy to have further conversations. You can just shoot us an email here on our site from info@indexenders.com, and we will get back to you as quickly as possible. Again, thank you very much for the time. I believe this has been recorded, so if you have colleagues that would like to watch this, again, send us an email and we'll get you that recording as well. Again, thank you for your time. Appreciate it and look forward to speaking with you in the future.